Think of these like countries importing and exporting products. Imagine a country that's importing wheat and exporting computer chips, whereas the other country, the anti-country, is importing computer chips, exporting wheat, or whatever, the opposite. So basically, it brings also economics into physics. The future physicists may be accountants, who knows. Getting back to gravity, I just want to show you what the Biefeld-Brown effect looks like. You charge upper surface of the saucer positive charge, lower surface negative charge. Subquantum kinetics is suggesting that the positive charges are consuming G and the negative charges are producing G. So you get a net G flux going this way, and of course it goes around. And therefore you get a gradient from minus to plus, which is opposing the Earth's gradient. That's all. That's very simple. The other thing, Brown found that if you make the negative plate smaller, you get more lift. And the reason for that may be what's happening is there's more of a radial flow of the etherons. So when you get a flow radially, you get the opportunity for a spiral. And very possibly this etheron flux may be spiraling, and they found that this has an effect of improving lift. Just want to show you the equations briefly. In subquantum kinetics, these are the equations that you can derive for for electrostatic potential. We'll talk just about electrostatic potential, forget gravity for the moment. And here is the classical electrostatics. See how similar they are? The difference is in classical electrostatics, they don't define what Q is. They just say it's charge. It's just something that they put in to represent that. Whereas here, we've defined it out of the basic equations. We defined it because that X is being consumed and Y produced in a certain region. This is a diffusion coefficient in subquantum kinetics, and that would be equivalent to permittivity. The minus and plus are for the two polarity particles that are possible. And always the Y is the mirror of X in terms of this is minus, this is plus. And from this you get fluxes, and these are the equations for the fluxes that we showed before. And this is what relates the flux to the potential. And this is standard in chemical kinetics. So all I'm doing is taking equations already been developed in chemical kinetics, applying them here. And here's the equation for electrostatic force field intensity from subquantum kinetics, and here's the standard one in electrostatics, and see again the great similarity. Eta is equal to 1 in this case, which is just a proportionality constant. Then from these you can derive these, which are the divergence and the curl, which are two equations of Maxwell's for electrostatics. And again, they're identical essentially to what is agreed. So I'm just showing you this to show you that it produces fields that are realistic, physically realistic. They're 1 over r potential fields, and the force fields are 1 over r squared. I don't really have time, unfortunately, to go into Panos Pappas' work, but just to mention briefly that Maxwell's laws have a flaw in that in his model he assumed that open circuits and closed circuits were behaving similarly. Just show a diagram. In other words, that these two circuits are identical. That physically closed circuit behaves identical to an open circuit where you have a capacitor here. Maxwell was assuming you had a displacement current flowing here. And Pappas's work has shown that there is no force that would be predicted. If there was a displacement current, there should have been a force, and his experiments didn't observe it. And it turns out that Maxwell based his electrodynamics on the Lorentz force formula, which this part is based on the Biot-Savart law, which predicts only transverse forces, magnetic forces, only transverse, not longitudinal. Pappas has found that the Ampere force law proposed by Ampere actually not only is it compatible with all the experiments that Maxwell's theory is compatible with, but also accounts for all the phenomena that Maxwell's equations don't. So this is the correct formula. And one thing that's different about it is it predicts not only transverse forces but longitudinal. For example, if you have a dipole antenna, you're going to have not only the transverse forces that Maxwell talked about, but also longitudinal forces of those waves. Here, good place to mention that. So here's the Maxwellian wave. In subquantum kinetics, here's what you have. Can you see that? High x, low y, and right next to it, high y, low x. That's all it is. And it moves forward. And this is a scalar wave. This is potential, energy potential, whereas here you're dealing with force vectors, okay? And this is very much like Tesla's concept, because Tesla was talking about the sound wave model, where you have compression and rarefaction of gas molecules in his gaseous ether. Here we have instead high concentration and low concentration of etherons. In other words, we have a chemical kinetic model. And chemical concentration is very similar to gas, except here you're dealing with ions in a solution, the density of ions, rather than concentration of gas molecules. So I think he would be very happy with us if he were here today. In fact, if he knew about chemical waves, he would have probably tried to work his theories into that model. This just shows one other experiment that Panos has done, the pi frame experiment. And with Maxwell's laws, you'd expect there was a force being applied here that was causing this pi frame to move forward when you put a current through it. There was another name for this, produced earlier.
Ampere bridge.
The Ampere bridge. Panos is designed a little differently, so it has more degrees of freedom. And when he rotates the current so it comes in from an angle from down, the bridge, instead of moving this way like Maxwell's equations would predict, moves upwards. And so these experiments, oh, and here's one other. This is the stigma antenna. He puts microwave radiation, and if Maxwell's equations were correct, there should have been forces here causing this to turn, and no forces were observed. And these two experiments not only disprove Maxwell's theory as a general theory, but also disprove special relativity, because the Lorentz force formula is a relativistic law, and these observations directly contradict special relativity. Here is the creation scenario for the universe. You have a particle by chance nucleating at a place where you have a sufficient supercritical region. And this supercritical region doesn't necessarily have to be the size of the particle. It can be a couple light years in diameter even. So proton comes into being. In the vicinity of the particle, another particle comes into being. Because the nature of this is that the particle produces a supercritical well and increases now the probability of further nucleations taking place. So the next particle that emerges is very likely to be in the vicinity of the previous particle. So it's sort of like a biological reproduction that goes on. And so you get mother and daughter atoms being produced. Eventually you get a whole primordial gas cloud. And this can take trillions of years. Okay, you're dealing with an evolution that's far longer in time. The thing is, you think, well, geez, the Earth is only 4.5 billion years old, and shouldn't most of the matter be relatively young? Well, that's the thing. This is an exponential process, so most of the matter is relatively young. But out of that, you'd find a certain percentage that was quite old. As the gas cloud is produced, it eventually condenses into a primordial brown dwarf, which grows into a star, ignites, then the mother star produces a daughter planet because of its stellar wind. The planet grows into a star itself, and this process goes on until you develop a whole star cluster, and that turns into a dwarf elliptical galaxy, of billions of stars. Then eventually the core, the mother star at the core, grows to such an extent, it becomes so energetic that it begins explosion activity. These are what are called galactic core explosions. And as a result, the explosive force blows gas and dust out, which circles along a plane and forms the spiral arms of the galaxy. And eventually, every now and then, if the explosion is very great, it will blow out a small cluster of stars, which will become a new galaxy, sort of like a spore forming a new galaxy. Now, this is not new. These ideas have been proposed, that the galaxies can form this way. ARP is one person that suggested this, and Ambertsumian, even before him. Okay. Now another aspect, this gets us into free energy, because if we're talking about spontaneous matter creation in space, obviously this is an example of free energy creation. But we also have not only matter creation, but energy creation. In regions where the gravity around, like let's say galaxies, where gravity is negative, you get supercritical regions, and in between the galaxies you get subcritical regions. Therefore, photons would tend to gradually, their energy dampen in the subcritical regions and gradually increase in supercritical. Now, this is nice because there's a model called the tired light model. For example, the whole idea of the expanding universe was based on the idea that they found that galaxy spectra were redshifted, meaning they saw the light was redder. The frequency was shifted from what they expected, and so the only solution they had was that it was because the galaxy was moving away. It turns out actually that one other guy had proposed a model about 8 years before the expanding universe model took root, a guy named Nernst, back in 1922 or so, that the ether was absorbing energy from the light, and that's why it redshifted. So actually, and this became later known as the tired light model. So actually, the tired light model should be given precedence over the expanding universe model. But this is not mentioned by the cosmologists. The nice thing about subquantum kinetics is it predicts this in a natural way. This is not something as an ad hoc postulate. It's something that emerges naturally from the equations. In fact, this was a test I carried out. I developed subquantum kinetics. I knew nothing about astronomy. This prediction came. I said, well, if this is true, maybe the redshift, could be due to this. And so I worked out the equation, and there's a certain exponential relation you'd expect that as you go out in space, the longer you go out, further you go out, the more redshifting you get. And that's an exponential form. And so I plotted against the data, and sure enough, it actually fit better than the expanding universe model. And this shows on the Hubble diagram test, galaxy redshift against distance. Here's the data, here's the tired light model, here's the expanding universe model. But not just on one test. This was the case on 4 different cosmology tests with 4 different data sets. And this was published in the Astrophysical Journal in 1986. And since that time, no one has refuted the results. So as far as I know, the expanding universe idea should be dead.